Okay, so today we are going to talk about motor control and why that is important. Not only motor control is important, there are also other issues with e-bike batteries, and that goes even more for the cargo e-bikes. Let me just talk about quickly the biggest issues that we're dealing with today, and that is battery unsafety. Uh, well, as we know, it happens more often that batteries get into fire or even explode. I will explain today um, that this is caused by low-end Chinese BMSs. But in this presentation, this is not being covered. But if you're interested in that as well, at 2 o'clock there is a next presentation here that focuses on battery management and safety. One point for BMSs is also battery longevity. Many people don't know that if you would charge the battery not to 100% but to 80%, then you get about double the lifetime of the battery. And nevertheless, most e-bikes and cargo e-bikes don't make use of that situation. The motor control, also low-end motor controllers are typically in use for pedelecs, and that's somehow acceptable because the performance is very small. But with cargo e-bikes, you have a much higher power if you do it right, and that means that there is more budget available to optimize the situation. And this is one of the things that this presentation is going to focus on how to deal with the better motor controlling. If we look at what are the consequences of when you cut the motor controller cost, then that means that you have less performance and less battery capacity than you could have when you would take a better motor controller. The same goes for BMS cost cutting. You could reduce the accident by just adding 3 to 3.5 euro extra to the BMS, and then I can guarantee that more than 98% of the e-bike fires are going to be over. Okay, for the motor controllers, let's first have a look at what went well during the past 12 years that I am a consultant and expert in this field. First of all, we see that microcontrollers which switch the system are much better, and motor qualities are also being improved. So that's good. However, especially in the low end, motor controllers do not use those improved components. And that means that since they work with very basic technology, advanced algorithms like fine-tuning, supervision, and use case algorithm, we'll talk about that later in detail, cannot be used. And that is a big difference, and even more important than the efficiency itself. So what we need to improve is both for low-end and higher-end e-bike, we want to improve the efficiency just by using a little bit better components. Not big money, but just a little bit better MOSFETs, if that tells you something. And the good news is that the higher cost that you invest in a better motor controller is directly coming back to you because the capacity of the battery goes up. Because if you have, for example, 6% efficiency, and you go down by better components to 3%, then it means that 3% of your battery cost, that's basically your budget. I hope that's clear. Of course, in many cases, purchasers will always focus on the level of each device individually. And if you do that, then you will say, yeah, it's more expensive. But if you notice that the efficiency is higher, so longer battery life, and you have better performance, then it's well worth it. So I know this is a very difficult subject, so I will try to not go into too much of the details. But I already told that the energy efficiency is the big thing here, as well as the algorithm gains. In the next slides, we will see minimum and maximum efficiency figures, whereby losses are subtracted from gains. I know this is a very new concept for everybody here, I guess, but I'll try to make it clear. So here we see the pure energy efficiency caused by the MOSFET, the component that switches. We call that switch losses. Then you see that different types of MOSFETs have different efficiency effect, and the losses are lower the better switch you use. If we take a look at the high end, that's over here. Then we see that when you take a heavy motor controller, then it makes sense to use quite expensive MOSFETs. And then you see here, the efficiency gain is primarily in the first range of the motor controller. Practically, though, we see that in the current market, high-end motors like 600 watt and more are not yet much used in the cargo e-bikes. So this is basically the most important thing to look at. And that shows in the orange blocks, it shows the switching energy efficiency, or in this case, the losses. Then we see that when you use different kinds of MOSFETs, there are some differences, but it's not really major. Yeah? It's like a few percent. But if you look at the gains that you use by a better motor controller, then you see the yellow and the blue block. That is showing the gain efficiency. So the gain that you get. And that is by what we will explain in the next sheet, by using better microcontrollers and much better algorithms. If we look at the cost efficiency, then as I explained earlier, it is basically a no-brainer. When you use better motor controllers, it doesn't cost more if you look at the cost savings. Even though it's still the future to use higher-end motor controllers, they use them already on motorbikes, but on cargo e-bikes, it's not yet used because they believe that the battery capacity would need to be too high to make that practically feasible. But if you have a look at two motor controllers, one that is a 48 volt using the very expensive gallium arsenide MOSFETs, that's at the left, then you see that the only benefit is the efficiency, but compared to the much lower cost MOSFET, the difference is not very big. It's like about 1% or less. If we look at the smart algorithm contribution in gain, that is much, much more. So that is the most important thing. Use a better microcontroller for this application. So that extra cost is only a few dollars, like $2 about. That will make the big difference. So the three algorithms that are implemented in those high-end microcontrollers are so-called fine torque current control. And that means that you have a much more precise control over the motor. And that means that you don't provide too much energy to the motor, and also not too less. Because in one case, you would have a better energy efficiency, and in the other case, a better performance. Supervision algorithm gains is maximizing the operation of the motor when it's in high efficiency mode. High efficiency mode means that you're accelerating most of the time, so like driving in city mode. And the system does that by monitoring the user behavior in every field, from driving slow to driving extremely competitive. And it optimizes the algorithm to fit best to that user. And that is also possible to save several percents by that. Then the use case gain is that since every motor has an operating point which is the most efficient one, the smartest thing to do is to choose your motor performance in such a way that your cruising speed is exactly the same as the highest efficiency points. That's very simple, but as far as we know, we're the only one that is proposing this yet. So if we look again against what kind of efficiency gains can you get, then if you compare that to the low-end motor controllers, then the benefit is almost bigger than the cost.
Wait.
This here is another effect of when you drive with a better motor controller. Then you can also implement a feature that you can drive away from standstill. We see how that works. Yeah. So you see here that normally with an e-bike, when you go up a hill, it's almost impossible. But you have to first wait until you have the first sensor that you see. But here it's almost costing no effort. And this is on a parking garage hill, so you can imagine. Okay, that concludes my story for today. As I mentioned, I will be back here to talk about battery management systems. And right now there is room for questions. If you would like to have a copy of the PowerPoint or have some questions for later, please copy the email.
So my question in general is about regenerative braking or constant feedback where the battery can be charged in a steady state ride. Where in the motor battery
Closer.
Where in the motor battery engine management system loop, where does the regenerative braking feature come into play, or does it?
Well, basically, you need to have a direct drive motor, otherwise it doesn't work. So that's the first condition. And of course, you need to have a controller that also supports that. And the benefit of regenerative braking, you have to see that is most important when you're driving in city mode, always accelerating and braking, because then the braking energy is brought back to the battery. It's not something that has much to do with the controller, because it's really a very simple thing. And even the low-cost controller could do that. So I wouldn't want to say that our motor controller is much better than others in that respect. Another thing you should consider is that direct drive motors often have a lower energy efficiency compared to the other ones, partly because of the way electrically, but also because they're heavier. So you have to always consider, is it worth it for my application? And generally, if you look in city driving, then it could be possible. But the most important gains are in the mountains. That's why our friends from Strömer, they use that, of course, the regenerative braking. Any other questions? And as mentioned, feel free to send me an email if you have more questions afterwards.
Anyone? Or we can...
We have more than enough room for questions, because after this is lunch.
Yeah,
so you can have a choice between eating and asking more questions.
Yeah, we have now almost an hour for a lunch break, and then we are back at 1. Yeah, so you can just throw questions to James during the lunch break. I think that we have the last question.
Thanks for our presentation. And I have a similar question regarding the regenerative braking. There are different companies are offering those kind of solutions, like Huntsman is one of them. They have a good motor, geared motor. It is not direct drive, it's geared motor, so has, I think, 100 Newton meter torque. And they can also offer, single shaft solution as well. So you can have it with one wheel, trike configuration. You can have both wheels on the reel. So they already provide those kind of solution, and they do have a decent controller with the properly made for the regenerative braking as well.
Okay, thank you very much for that suggestion. Frankly, I wasn't aware that because regeneration is not really much in our vocabulary, because it's, as I said, it's more important when you're in a hilly area. But I will certainly bring that up to our team. Thank you very much.
I think that, yeah, we can finish the session. Thank you very much, James, for your presentation and all your knowledge. Big applause for James, please.